So our focus question today is how do you write equivalent expressions using the distributive property? And when we talk about that, we're looking for how do you write expressions like math sentences that are equal. So in your notebook, I hope you've written down the distributive property, and I just like to call it sharing the love because you get to share a number between lots of different numbers. This next line you don't need to write down, but I want you to think about when people distribute things or when they pass out things. So if you've watched me before distribute papers or pass out papers, okay? Somebody might distribute flyers, or if you've ever been to a parade, people will distribute candy and they'll pass it out to lots of different people. So the distributive property involves breaking apart numbers into two numbers that are easier to work with. It can be more than two, but we're just going to talk about two today. For example, 36 can be split up into 30 plus 6, 35 plus 1, or 40 minus 4. Go ahead and write this part right here down in your notes. So this right here, please. So earlier today when we solved that problem of 23, was it 23 times 4, Matthew?
Yeah.
And Matthew rounded it up to 25.
Or I did 20 times.
Oh, you did 20. That's right. You did 20 times 4 and then 3 times 4 in order to solve that one. So it's just how you decide to split up your number. To be able to work with it a little easier. Now I will tell you that we most often split up numbers into tens and ones, which is what happened with this 30 plus 6. You don't always have to do that, but that's just most often what happens in order to be able to look at problems. I would make sure to get those examples in your notes, just so you know exactly what we're talking about today. One more time, that's the distributive property involves breaking apart numbers into two numbers that are easier to work with. For example, 36 can be split into 30 plus 6, 35 plus 1, or 40 minus 4. So we have a couple of examples that I wanted to check out. And this goes back a little bit to some of the mental math strategies that we opened with today. So think for yourself about solving the problem 4 times 36. Think to yourself, how would you solve 4 times 36? Just think about it in your head rather than writing it down. So two ways that you might think about solving this. If we have the problem 4 times 36 here, we can think about it two different ways. We can think about it as 4 times, in parentheses, 30 plus 6. Or we can think about it as 4 times 30 plus 4 times 6. So look up here because I want to show you what's happening. When you decide to use the distributive property, you're going to take that first number, and it's like kind of passing it out, sharing the love between other numbers. So this 4 goes with the 30, and then the 4 also matches up with the 6. call this first way factored form. I would write that in your notes. This is the factored form. And this next way that you see it is expanded form. You do need to know the difference between these two forms, but you also need to know that they are equivalent. They equal the same thing. So all of those math sentences, math expressions that we have up there are all equivalent, or they equal each other. Turn to the person next to you and explain, how does that 4 get passed out so that the factor expression is equal to the expanded form? Go for it.
Jolly Rancher.
That's
Now, are you guys interested in making sure that they're all equivalent? I know that you trust me, but should we just double check?
Yeah.
Okay, so let's do this. I'm going to start with 4 times 36, and I'm just going to do this just using a stacking strategy. Okay. And I have that 4 times 6. Everybody, what does that equal? Oh, let's try that again. 4 times 6, what does that equal? 24. Okay, think to yourself, what is 4 times 3? Plus 2? What is that, everybody? 14. So all of our expressions should be equivalent to 144. Okay, so let's check this next one, shall we? You guys cool with that?
Yes.
Okay, so if we pay attention to the order of operations, Beatrix, what am I going to do first when I look at that factored form?
Oh, factored form?
Yeah, what am I going to do first?
So you're going to do the 30 plus 6.
Yeah, I'm going to do 30 plus 6. So then this one, our next step would be 4 times 36, right? Which we already figured out was 144. Okay, so those two are equivalent. Okay, let's look at our one over here. Caroline, would you like to help me with this one?
Sure.
Okay.
So 30 times 4 is 120.
120. Okay.
And 4 times 6 is 24. Yeah, so it'd be, oh, I get it, 140.
Good job. Thanks for letting me put you on the spot. Nice job, lady. So those are all equivalent. CJ, what's your question? Oh, I love that you were paying attention. Great job. Okay, so down here, I have a picture. Because I always love using arrays. I love arrays so much. So I have a picture to help explain 8 times 14. I want you to look up here to see what it looks like before you put this in your notes. Okay? I have an array that is 8 on this side. It's 8 cubes on this side by 14 on this side. Okay? Now, to make this a little bit easier for myself, I decided to split this up into 8 times 14, but I split this 14 up into 10 and 4. So instead of thinking of my problem as 8 times 14, I can think of it as 8 times 10 plus 14. Or this part in green right here, do you see how this green part is equivalent to 8 times 10, which would be this right here. And the red part, this dimension is still 8, is equivalent to 8 times 4. So any way that I decide to write it, I am still going to get the same number of squares. So if I just choose to solve this right here, I'm going to solve it this way because that's how I like to do it the best. I would have 80 plus 32. So I should have a total of 112 squares. I'm going to give you guys a minute to copy this into your notes, and then I'll answer questions. So take a minute and copy that into your notes. If you have questions, raise your hand, and I'll come around and I'll check in with you. I would go ahead and do that picture in your notes too. That's going to be real important so you understand how this actually works. So just to go over this one more time, this whole array here, the whole array here is 8 times 14. But if we want to split up the 14 into tens and ones, we can say that we have 110, and then we have 4 ones. The portion inside the bigger rectangle here is 8 times 10. Okay? The portion in the smaller rectangle right here is 8 times 4. So I can think of this as being 8 times 14. I can think of it being 8 times 10 plus 4. Or I can think of it as 8 times 10 plus 8 times 4. So there are a couple of different ways that I can think about it, but all of those expressions are equivalent, which is a really cool thing that you have lots of ways to solve problems. In your notes, I would love for you to start off by trying 6 times 19. What would that look like in factored form? And what would that look like in expanded form? Let me give you a couple of minutes to try that by yourself. I'm seeing some kids do some cool things with arrows. I'm going to move this a little bit. There we go. So I'm just going to represent 6 times 19 as an array. 6 times 19. And I'm just going to do an open array here, so I'm not going to draw all of my squares. Okay. I'm going to choose to split this up into tens and ones. 10 and 19. So I can represent this in factored form as 6 times 10 plus 9, which is equal to, I'll do this in colors right here. Which is equal to 6 times 10, which is just this part right here, plus, and I hope this is what you have written down. If not, you have a chance to make sure to correct your work. And here would be 6 times 9. Yes, sir.
Oh, I found when I did it on the graph paper that 10 is almost equal to 9, so it's just like one line almost.
Yes. So you're right. If I were to draw this again, I should probably make these about the same size.
Yeah.
Thank you for bringing that up. So if I want to solve this, the area of the part in red is going to be 60. The area of the part in blue is going to be 54. I can add those together. Well, I can add those together, and I can end up getting 114, which would be my total area. Now, if you wanted to get fancy, and if you chose to use this and do this with subtraction, and maybe think of it as 6 times 20 minus 6 times 1, you could do that as well. All right, you have one more. Go ahead and try 47 times 9. I'm seeing some beautiful notes, ladies and gentlemen. Bless you. So I'm going to take the 9, and the 9 is the one that I'm going to distribute. So in factored form, I can say that I have 9 times 40 plus 7. If I want to take that 9 and pass out to the 40 and then pass out to the 7, I can get my expanded form. Now be careful that you know that that's a 40 and not a 4. So my expanded form is going to be 9 times 40 plus 9 times 7. And that's what you should have for your second problem there. So if I read this one more time, it says a large rectangle has an area of 28 square units. It has been divided into 2 smaller rectangles. One of the smaller rectangles has an area of 4 square units. What are the possible whole number dimensions of the large rectangle? Justify your reasoning. Okay, so we know that one of them is 4. The total area is 28. Can you raise your hand and tell me if you have an idea, what is the area of the second rectangle here, this one right here? I see 1, 2, 3, 4, 5, 6, 7 brave kids. Think about it. If the whole area is 28, and we already know where 4 of it is, Reese, what's going to be the area of this second one right here?
7 square units.
So if we know that this is 4, we're looking at the total area, not just like along the top, but the total area.
Oh, 4 times 28, you say? Oh.
Well, we know that if we look at this whole thing, the whole thing is 28, right? And we already know that this is 4 square units right here. So what's going to be the area of this part right here? We have 28. We're going to take away 4 because we already know about 4 of them. Yeah, 24. So this one right here is going to be 24 square units. Okay, so now what we need to do is we need to figure out what could the possible dimensions be of this. And you're going to need to go back to what you did when you were thinking about common factors. So talk to the person next to you. What could be some factors that we could have? What could some possible dimensions be for this? Go for it.
Two and 12. 2 on one side.
24 plus 4
4, 3, 2, 1, and 0. Who has an idea for what the possible dimensions for this could be? Caitlin? 2 times 12? Just for the whole thing, would 2 times 12? No, keep going. I think you have a great idea. Keep going. What are you thinking?
Well,
Are you thinking that this could be like 2 times 12 right here? Do you want to add on to that?
you could do 2 times 19, the whole thing.
We could. I want to show you guys something. If I take this, is 2 times 2 4?
Yeah.
Is 2 times 12 28? Is 2 times 14 28? Yeah. So I can think of this as 2 times 14. Please wait. I can think of this as 2 times 2 plus 2 times 12. Or I can think about this as 2 times 2 plus 12. And that would also be another way that I could get my answer. Okay? All right.